So whenever we come to factoring a polynomial, the first step is always look and see, do we have a GCF to factor out? So the first step to factoring is looking at my numerical GCF. The second thing we look at is, do we have a variable? We have to have an x in all terms or a y in all terms, otherwise we don't have a variable GCF. And the final thing that we do is we put the GCF outside parentheses, and inside parentheses will be the quotient of all terms divided by the GCF. This is the complete opposite of the distribute property. So with our example, we first look at 6, 12, and 24. In the previous video, we said that 6 is our smallest number, and the factors of 6 are 1, 2, 3, and 6. Well, 6 goes into 12 and 24, so that is my greatest common factor. If you were to factor out a 2, you'd have to break it down even further. So 6 is my numerical GCF. I can put that on the outside of what will be my distributed term. I then look at my variables. I have an x squared, an x cubed, and an x to the 4th power. Well, what I can clearly see is they all have 2 x's in common. So my numerical GCF is 6x squared. Now the problem comes in that some people leave this out of their answer. Remember, the double check for this formula is if I factored it correctly, I would distribute and come back to my original answer. So I need to see this quotient after I divide each term by 6x squared. The biggest mistake students make is they say, oh, well, anything divided by itself cancels. Well, that's true because anything divided by itself is 1. 12 divided by 6 is 2. And remember properties of exponents? We subtract when we divide. 3 x's on top of 2 x's, 3 minus 2 is 1. 24 divided by 6 is 4. And again, same concept, 4 x's divided by 2 x's leaves me with 2 x's. And that is the answer to our factored polynomial.